The next question is before us. This is question number 8. In this question, two quadratic polynomials have been given. One is f of x equal to ax square plus bx plus c, and the other is g of x is equal to ax square plus px plus q, where a, b, c, p, q are all real numbers and b is different from p. If their discriminants are equal, a valuable information it is. The two polynomials of course have the same discriminant, and f of x is equal to g of x has a root, say alpha. Then a will be the aim of the roots of f of x equal to 0 and g of x equal to 0. A will be the gm of all the roots of f of x equal to 0 and g of x equal to 0. A will be the aim of roots of f of x equal to 0 or g of x equal to 0. And the last option is a will be the gm of the roots of f of x equal to 0 or g of x is equal to 0. Let us see what is going to happen. First of all, what are the polynomials given? First one is f of x is equal to ax square plus bx plus c. And the second one is g of x is equal to ax square plus px plus q. That is a quadratic, and this is also a quadratic. Okay. Let alpha, beta be the roots of f of x equal to 0 and gamma, delta be the roots of g of x is equal to 0. From this, alpha plus beta is minus b by a and gamma plus delta is minus p by a. It's very simple. Let me change this name alpha and beta, because in the question itself alpha is given. Let us use a separate name, say alpha 1 beta 1 gamma 1 delta 1 be the roots of those two equations. Well, we have not yet used the entire information given in the data. What are the things remain here still to be used? F of x is equal to g of x as a root. What does it mean? Alpha is a root of f of x is equal to g of x. Implies f of alpha is equal to g of alpha. Implies, isn't it? Alpha is the root of this. So what should happen? F of alpha is equal to g of alpha. Come on, substitute alpha in f of x. What does it become? A alpha square plus b alpha plus c is equal to a alpha square plus p alpha plus q. Right? We can easily cancel a alpha square. Then what happens? This implies alpha into b minus p is equal to q minus c. From there you have alpha is equal to q minus c by b minus p. Alpha is equal to q minus c by b minus p. Well, let us keep this at a side. You can notice now, still there is another information to be used. What is that information? These two equations f of x equal to 0 and g of x equal to 0 have same discriminants. What is the discriminant of the first one? B square minus 4ac. B square minus 4ac is equal to p square minus 4aq. Implies b square minus p square is equal to 4ac minus 4aq. Therefore, b minus p into b plus p is equal to 4a into c minus q. Implies b plus p by c minus q is equal to b minus p by 4a or b plus p by 4a is equal to c minus q by b minus p. But we have q minus c by b minus p is alpha. Hence, we can write this as minus alpha. Implies alpha is equal to b plus p by minus 4a. b plus p by minus 4a. Again, this can be taken as minus b by a plus minus p by a by 4. But what is minus b by a? Alpha 1 plus beta 1. What is minus p by q? What is minus p by a? Gamma 1 plus delta 1 by 4. Alpha is equal to. What are we able to observe this? Alpha 1 plus beta 1 plus gamma 1 plus delta 1 by 4. That is the arithmetic mean of all the roots of f of x equal to 0 and g of x is equal to 0. Therefore, what is the correct option? Option A is the right option. The next question before us is question number 9. This question is, the two equations x square plus 2 lambda x plus lambda square plus 1 is equal to 0 and ax square plus bx plus c is equal to 0 have a common root. Basically, here small a, small b, small c are the lengths of the sides of a triangle. Then the possible range of values of lambda is, he has introduced lambda in the first equation and he has promised that lambda is a real number, that is lambda belongs to R. Now, we are bound to know the range of values of lambda. Let us see. What is the first equation? X square plus 2 lambda x plus lambda square plus 1 is equal to 0. And the second equation is ax square plus bx plus c is equal to 0. Let us observe this equation very carefully. What can we understand by looking at those three terms? It is just nothing but x plus lambda whole square plus 1 is equal to 0. This is a perfect square. This is a positive number. X plus lambda whole square can never be negative. It cannot be negative. Therefore, this equation does not possess real roots. Has no real roots at all. Has no real roots. Then what happens? It should have imaginary roots. That too complex conjugates. That is, if alpha plus I beta is a root of this equation, then the other root must be alpha minus I beta. One more thing, important thing here is these two equations have a common root. Say alpha plus I beta is the common root. Automatically and clearly, evidently, alpha minus I beta is also the common root. It means that these two equations have same roots, or both the roots of the two equations are common. Let me call this equation 1. Let me call this equation 2. Therefore, 1, 2 have both the roots common. Both the roots common. What happens in that case? The two equations coincide. Rather, the coefficients can be compared with. Let us do that. A coefficient of x square is a. Here it is 1. Therefore, a by 1, b by 2 lambda, c by lambda square plus 1. Let me suppose this sum k. From this, a is equal to k, b is equal to 2 lambda k, and c is equal to lambda square plus 1 into k. Okay, we could have estimated a, b, c in terms of lambdas and k's. Another important information is given in the data. What is that? What are small a, small b, small c? They are the sides of a triangle. Therefore, we must have A plus B greater than C. Not only that A plus C greater than B, not only that B plus C greater than A. Of course, we call it the triangle inequality. In any triangle, sum of the lengths of two sides is strictly greater than that of the third side. By making use of that, we are able to have A plus B greater than C. But what is A? K. What is B? 2 lambda K. What is C? Lambda square plus 1 into K. By ignoring K, we see that 1 plus 2 lambda greater than lambda square plus 1. Again, by ignoring 1, 2 lambda greater than lambda square, or lambda square minus 2 lambda less than 0. That is lambda into lambda minus 2 less than 0. The very last step indicates and reveals that lambda should lie between 0 and 2. Lambda lies between 0 and 2. Lambda belongs to open interval 0 to 2. Hence, the correct option among the given options is option A, because option A is open interval 0 to 2. Let us move towards to deal with the question number 10. That is the next question. Let f of x is equal to x square plus 5x plus 6. Then the number of real roots of the equation f of x whole square plus 5 into f of x plus 6 minus x equal to 0 is. What is f of x? F of x is equal to x square plus 5x plus 6. What do we want to have? Number of real roots of the equation. What is that equation? F of x whole square plus 5 into f of x plus 6 minus x equal to 0. The number of real roots of that equation we want to have. The first option, that is option A, is 1, option B is 2, option C is 3, and option D is 0. Let us see. Here, of special interest is the case with this problem to observe. You observe this equation carefully. F of x whole square plus 5 into f of x plus 6 is equal to x. What is the speciality in this step? You observe carefully, it is just nothing but f of x. Now we shall think of, if you consider f of x is equal to x, then the nature of the roots of f of x is equal to x and f of x is equal to x will be same. Why? Because if you replace f of x by x, the same equation will going to be obtained. Therefore, if f of x is equal to x have any type of roots, similar is the type of the roots of this equation. Let us now observe that equation carefully. What is f of x is equal to x? X square plus 5x plus 6 is equal to x. It means that x square plus 4x plus 6 is equal to 0. Here the discriminant d, what is discriminant? B square minus 4ac is less than 0. Therefore, f of x is equal to x has imaginary roots, that is, it cannot possess real roots. Therefore, f of x is equal to x also has no real roots. Has no real roots because has no real roots since f of x is equal to x has no real roots. Therefore, number of real roots of the given equation is 0 because there are no real roots at all. So, the number of real roots present is simply 0. The fourth option is of course the right option. The next question, that is question number 11. If f of x is equal to x square plus 2bx plus 2c square and g of x is equal to x square minus 2cx plus b square are such that minimum of f of x is greater than maximum of g of x, then the relation between b and c is. We are given two types of quadratic polynomials. One polynomial is, this is actually question number 11. One polynomial is f of x is equal to x square plus 2bx plus 2c square. And the other polynomial is g of x is equal to minus x square minus 2cx plus b square. Let us observe them very carefully. This is equal to x square plus 2bx plus b square minus b square plus 2c square. This is x plus b whole square plus 2c square minus b square, isn't it? This is a perfect square, so this is greater than or equal to 0. So total is greater than or equal to 2c square minus b square. From this step itself, we notice that minimum of f of x is equal to 2c square minus b square. Let us stop here. We could have known the nature of f of x, and we could have estimated the minimum of f of x, that is 2c square minus b square. Absolutely in the similar fashion, let us look at g of x. What is the fate of that? Let us observe. This is nothing but b square minus of x square plus 2cx. Am I correct? Of course, it is right. This is therefore equal to b square minus x square plus 2cx plus c square plus c square. Minus of plus c square is minus c square, and plus c square, they go away. It makes no difference and it makes no harm. So this is equal to b square plus c square minus of x plus c whole square. X plus c whole square. X plus c whole square. B square minus of x square plus 2cx plus we have added and subtracted 1c square. Therefore, this is a perfect square. This is a non-negative number, hence this is less than or equal to b square plus c square. From this, we are able to notice that the maximum of g of x is b square plus c square. Why? Because g of x, the value of g of x can never exceed b square plus c square. It is less than or equal to b square plus c square. He is saying, we could have got it. Therefore, g of x is less than or equal to b square plus c square, implies maximum of g of x is of course equal to b square plus c square. Let us now think of the actual thing given in the data. He has said that minimum of f of x is greater than maximum of g of x. Let us now make use of that. Minimum of f of x is greater than maximum of g of x. He has said, he has given. Let us make use of that. What is minimum of f? 2c square minus b square is greater than b square plus c square. B square plus c square. Bring that c square here, send this b square to that side. What is going to happen? C square is greater than 2b square. C square is greater than 2b square. Let us now observe the square roots, positive square roots on both the sides. We shall have mod c is greater than root 2 into mod b. Mod c is greater than root 2 into mod b. Therefore, among all the four options, the fourth option, that is option D, is correct. Mod c is greater than root 2 into mod b. The actual essence of this question is, you must be able to know the maximum of g of x and minimum of g of x on this part. In order to make use of the given condition, that is minimum of f of x is greater than maximum of g of x, it is essential. By making use of that, it is a very easy matter to get the answer as mod c greater than root 2 into mod b. That is, the fourth option is the right option. The next question before us is question number 12. The number of solutions of the equation x squared plus integral part of x minus 4x plus 3 is equal to 0 is first option. That is option A is 0, option B is 1, option C is 2, and option D is 3. Let us observe the given equation with special interest. What is the given equation? X squared plus integral part of x minus 4x plus 3 is equal to 0. Let us now recollect the nature of integral part of x. Integral part of x plus fractional part of x is equal to x is an easy matter to know the definition and symbolism, to recollect and remember. This we call integral part of x, this we call the fractional part of x. If you club these two, you'll be going to get x. Suppose x is some 2.4, something like that. 2 integral part, 0.4, there is the fractional part. If you club them, you'll be going to get 2.4, that is x. Well, let me represent this fractional part with some f. See, right? Therefore, integral part of x is equal to x minus f. As this is the fractional part, clearly 0 is less than or equal to f is less than 1. If x becomes an integer, then integral part of x is equal to x, then the fractional part becomes 0. Otherwise, it lies between 0 and 1. Therefore, the nature of the fractional part of any real number lies between 0 and 1. 0 less than or equal to f less than 1. Let us use this symbolism here in the given equation. What happens to the fate of this equation? X square plus, in the place of integral part of x, you can write x minus f minus 4x plus 3 is equal to 0. Therefore, x square, x minus 4x is minus 3x plus 3 is equal to f. Is equal to f. But we know that 0 less than or equal to f less than 1. But 0 less than or equal to f less than 1. That is, in the place of f we can write x square minus 3x plus 3 lies between 0 and 1. Lies between 0 and 1. Here, 3 possibilities may occur. Out of them, the first one is, if this is 0, what happens? This is either 0 or greater than 0. 2 cases arise for this particular inequality. Let us first observe what happens when this is 0. Observe that equation. X square minus 3x plus 3 is equal to 0. What is the discriminant of this equation? B square minus 4ac. 9 minus 12 minus 3. Negative. Discriminant of this particular expression is negative. Therefore, x square minus 3x plus 3 is equal to 0 does not possess real roots at all. Therefore, x square minus 3x plus 3 cannot be 0. Cannot be 0. Hence, it should lie between 0 and 1. X square minus 3x plus 3 is less than 1. Now, let me observe this inequality. X square minus 3x plus 3 less than 1 means x square minus 3x plus 3 less than 1. Bring 1 here, plus 2 less than 0. And it is an easy matter to trace the factors of this one. X minus 1 into x minus 2 less than 0. X minus 1 into x minus 2 less than 0. What happens? X belongs to open interval 1 to 2. So, x lies between 1 and 2 to 2. Therefore, value of x is 1 point something. Greater than 1 and less than 2. Let it be some 1.556, something like that. Then, what is the integral part of x then? Integral part of x then is 1. Isn't it? 1 less than x less than 2. What is the integral part of x? 1. If integral part of x is equal to 1, what happens to the fate of the given equation? What is the given equation? X square plus integral part of x minus 4x plus 3 is equal to 0. That is x square plus 1 minus 4x plus 3 is equal to 0. That is x square minus 4x plus 4 is equal to 0. That is x minus 2 whole square is equal to 0. That is x is equal to 2. Well, you please observe these two results. What can we say? These two are absolutely mutually contradictory. This says that x lies between 1 and 2. That says that x is equal to 2. How can it happen simultaneously? So it cannot happen. Therefore, this equation will have no real roots at all. Therefore, the number of real roots of the given equation is therefore 0. Hence, the right option among the given options is option A. Option A is the right option. We could have arrived at the correct answer by remembering that integral part of x plus fractional part of x is x, and by writing this integral part of x in terms of f. The right option is, that is, the number of real roots is 0. The next question is, there has been given a function f of x equal to x minus integral part of x, and we are asked to find the number of solutions of that equation f of x plus f of 1 by x is equal to 1. F of x is x minus integral part of x, and we need the number of solutions of the equation f of x plus f of 1 by x is equal to 1. Option A is 0, option B is 1, option C is 2, and option D is infinite. Let us observe. F of x plus f of 1 by x is equal to 1. What does this mean? What is f of x? X minus integral part of x. What is f of 1 by x? 1 by x minus integral part of 1 by x is therefore 1. Implies x plus 1 by x is equal to integral part of x plus integral part of 1 by x plus 1. Well, integral part of x and integral part of 1 by x by the very name itself indicates that they are integers. This is an integer, this is an integer, this is an integer. Therefore, LHS must also be an integer. Implies x plus 1 by x must also be an integer. Why? Because since RHS belongs to Z, that is the set of integers. Why should we believe that? Integral part of x, integer. Integral part of 1 by x, integer. 1, integer. Their sum is also an integer. Therefore, LHS must also be an integer. Let that integer, the so-called integer, be some k. Some k. Let us multiply this on both sides with x. Let us see what happens. X square plus 1 is equal to kx, or x square minus kx plus 1 is equal to 0. From this, what is the value of x? Minus b plus or minus root of b square minus 4ac by 2a. X is real. X is real. Therefore, what must we have? K square minus 4 greater than or equal to 0. That is k plus 2 into k minus 2 greater than or equal to 0. That is either k less than or equal to minus 2 or k greater than or equal to 2. Of course, if this is 2 or minus 2, equation cannot be satisfied. Therefore, what should have? K less than minus 2 or k greater than 2. K greater than 2. How many such k's are possible? How many integers are there below minus 2 and above 2? Infinitely many. Definitely, there are infinitely many integers k with that condition. Therefore, the number of solutions of this equation will also be infinite. Hence, the right option among the given options is option D. In this question, we have been given a lengthier polynomial equation of 8th degree has been given. That is, the equation a8 x power 8 plus a7 x power 7 plus a6 x power 6 plus and so on, etc., etc. a1x plus a0 is equal to 0 has all its roots positive and real. It has real roots and positive roots also. It has also been given that a8 is equal to 1, a7 is equal to minus 4, a0 is equal to 1 by 2 power 8. Then he is asking us the values of either a1 or a2. First option, that is option A, is a1 is 1 by 2 power 8. Second option, a1 is minus 1 by 2 power 4. Third option is A2 is equal to 7 by 2 power 5. Fourth option, that is option D, is A2 is equal to 7 by 2 power 8. Let us observe. First of all, what is the given equation? A8 x power 8 plus A7 x power 7 plus A6 x power 6 and so on, etc., etc., etc. A1 x plus A0 is equal to 0. Something has been given about the coefficients also. Let us trace them. What is A8? A8 is equal to 1. That is, the leading coefficient is 1. And A7 is minus 4. A7 is minus 4. That is, the second coefficient is minus 4. A0, that is the last coefficient, is 1 by 2 power 8. 1 by 2 power 8. Let us try. Okay, this is an equation of 8th degree. How many roots does it possess? 8 roots. Let alpha 1, alpha 2, alpha 3 and so on, alpha 8 be the roots of. Let me name this given equation to be some 1. What is the sum of the roots? Alpha 1 plus alpha 2 plus alpha 3 plus etc. alpha 8 is equal to how much? Minus A7 by A8. What is A7? Minus 4. What is A8? 1. So this is 4. This is 4. Again, product of the roots, alpha 1 into alpha 2 into alpha 3 into etc. alpha 8. How much it will be? This is A0 by A8. What is A0? 1 by 2 power 8. What is A8? 1. Hence it is half power 8. Let me call this equation 2. Let me call this sum 3. 2 implies alpha 1 plus alpha 2 plus etc. etc. alpha 8 by 8 is equal to 4 by 8 is half. 3 implies the third relation. From this, what can we have? We take 8th powers on both the sides. What is going to happen? Alpha 1 into alpha 2 into etc. alpha 8 whole to the power of 1 by 8 is again half. You please observe carefully. This is the AM of the roots. This is the GM of the roots. Isn't it? Both are equal. So, these two say that AM is equal to GM. And in general, arithmetic mean and geometric mean, generally they do not coincide. If at all they do coincide, then the numbers of whose AM or GM is found are equal. That is, from this we can say that alpha 1 is equal to alpha 2 is equal to alpha 3 is equal to alpha 8 is equal to half. Then only we can observe that the AM and GM coincide. Of course, they are coinciding with half. Therefore, alpha 1 is half, alpha 2 is half, etc., etc. Alpha 8 is also half. Let us now observe the question. What do you want to have actually, either A1 or A2? Which is easier? Let us have A1. What is A1? The last but first coefficient. Isn't it? So, A1 occurs in what type of function of the roots? Sum of the products of all the roots taken 7 at a time. You have it. Isn't it? Therefore, A1 by A0 is equal to minus 8C7 half power 7, because every root is half. What is minus 8C7? 8C7 is nothing but 8C1. 8C1 is nothing but 8. 8 is nothing but 2 cube. 2 cube by 2 power 7. What does it mean? Minus 1 by 2 power 4. But A0 is of course 1. A1 occurs in some of the products of the roots taken 7 at a time, and hence it is just nothing. A1 by A8 is therefore equal to minus 8C7 into half power 7. But A8 is 1. A1 by 1 is A1. From this we have A1 is equal to minus 1 by 2 power 4. The correct option is therefore option B, that is the second option. A1 is equal to minus 1 by 16 is the correct answer. The next question. In this question, f of x is a polynomial of least degree such that f of r is equal to 1 by r is equal to 1, 2, 3, etc. 9. Then what is f of 10? First option, that is option A, is 1. Option B is half. Option C is 1 by 10. Option D is 1 by 5. What is the relation given? F of r is equal to 1 by r is equal to 1, 2, 3, etc. 9. Implies r into f of r is equal to 1 implies x into f of x minus 1 is equal to 0 has the roots 1, 2, 3, etc. 9. You can trace it. By making use of this, we can estimate, or rather we can assume that x into f of x is equal to some constant a into x minus 1 into x minus 2 into x minus 3 into and so on x minus 9. Why is it possible? X is equal to 1 is a root, means x minus 1 is a factor. X is equal to 2 is a root, means x minus 2 is a factor. Proceeding like that, x minus 9 is also a factor. And he has assured that f of x is a polynomial of least degree. That is why we can assume that this equation is a polynomial of 9th degree, because 9 factors are surely present here. Therefore, we assume f of x like this, x into f of x like this. Here, we need to find capital A first of all. Why? Because unless you know f of x very clearly, you cannot get f of 10. Therefore, to have f of x perfectly, clearly, we must be able to know what capital A is. As this is an identity, we can take whatever real value we can take in the place of x. Let me take x equal to 0. X is equal to 0 implies 0 into f of 0 is 0 is equal to a into 0 minus 1 into 0 minus 2 into 0 minus 3 and etc. 0 minus 9 by 9 times, that is minus 1 whole power 9 into 9 factorial. X into f of x minus 1 is equal to, because this has those roots. Well, this is 0 minus 1 is equal to implies a into 9 factorial is 1. Therefore, a is equal to 1 by 9 factorial. A is 1 by 9 factorial. We could have known what a is. After knowing a, let us have x into f of x minus 1 is therefore is equal to 1 by 9 factorial into x minus 1 into x minus 2 into and so on x minus 9. What type of value you would like to have? F of 10. Taking x is equal to 10. X is equal to 10 implies 10 into f of 10 is equal to, send minus 1 to that side, 1 plus 10 minus 1, 9, 10 minus 2, 8, 9 into 8 into 7 into 6 into etc. 1 by 9 factorial. This is 9 factorial. By 9 factorial gives you 2. Therefore, 10 into f of 10 is therefore 2. Implies f of 10 is equal to 2 by 10, that is 1 by 5. The correct option available among the given options is option D, that is answer is 1 by 5. Fourth option, that is option D, is the correct answer. The next question, that is question number 16. In this question, if one root of the equation x square minus 4x plus a plus f of a is equal to 0 is 3 times that of the other, then minimum value of f of a is, he is asking us. Well, what is the given equation? X square minus 4ax plus a plus f of a is equal to 0. is 3 times that of the other. So the roots will be in the ratio 1:3. Let me call this equation 1. Let the roots of 1 be alpha comma beta. From data, what is beta? It is thrice of alpha. He is saying 3 times that of the other root. So alpha and 3 alpha are the actual roots. Now I like to use it as the ratio between alpha and beta is 1:3. Why? Because in our from our earlier knowledge of quadratic equations and expressions, we could have had a beautiful formula. If alpha is to beta is equal to m:n. If alpha is to beta is equal to m:n, that is, if the roots of a quadratic equation are in the ratio m:n, then what should we have? What should we have? B square by AC is equal to m plus n whole square by mn. In the case of a general quadratic equation, ax square plus bx plus c is equal to 0. That is a well-known result, which is known to all of us. Such a famous result it is. Let us now make use of that. Alpha is to beta is 1:3. So in that connection, in the place of m and n, what are we supposed to have? 1 and 3. Let us make use of that. What is b? B is nothing but minus 4a. B square means 16a square by az. 1 into this. A plus f of a is therefore equal to m plus n whole square. That is 1 plus 3 whole square by 1 into 3 is 3. What is 1 plus 3? 4. 4 square 16. They go away, leaving you a plus f of a is equal to 3a square. Therefore, f of a is 3a square minus a. F of a is 3a square minus a. Why is it necessary to get f of a like this? Because we want to have the minimum value of f of a itself. Well, let us take care of this f of a. What is f of a? F of a is equal to 3a square minus a plus 0. Let me say. As the coefficient of a square is positive here, this is supposed to have the minimum value. And from our earlier knowledge of quadratic expressions, the minimum value of a quadratic expression, if at all it does exist, is 4ac minus b square by 4a. 4ac minus b square by 4a. This, therefore, minimum value of f of a is equal to 4ac minus 4ac b square by 4a. This is nothing but this is 0, this is minus 1, hence it is minus 1 by 12. What is the minimum value of f of a? It is minus 1 by 12 and it is available, of course, in among the fourth option is the correct option. It lies among the given options. Option D, that is minus 1 by 12 is the correct answer.